Hi everyone, we've got a nice simple question to go through today. So what the question in front of us is asking us is for a voltage drop. Calculate a volt drop, 5 kilowatt, single phase circuit. It's Tony Woods wired in, it's in 4mm single core, 70-degree thermoplastic cable, 25 metres long, and installed in accordance with reference method A. So to do this sort of question, we're looking at the regulations. I'll move my head out of the way there. So the regulations, I'm on page 401 of the blue regulations, so amendment 1. If you went to amendment 2, the pages will be slightly out. So a single core at the top, 70-degree thermoplastic, non-armoured, with or without sheath. Reference method A is the first couple of columns. Column number 1 is your cable size. Column number 2 is single phase. Column 3 is three phase. So we're looking at single phase, which is column number 2. So what we need to consider first, when looking at this sort of question, we need to consider the kilowatt is not really what we're looking at. So it says 5 kilowatts. So 5 kilowatt, we need to convert that across into current. So current, I, is power over voltage. So 5,000 divided by 230. So what we'll do, I shall get a calculator and I'll get the calculator to float because I don't really want it in the way. Where can we put it? I'll put it at the bottom there. So I'll clear my calculator from last time I used it. So fraction symbol when we're doing any calculation that involves division. 5,000 divided by 230. Oh, get rid of that at the top because I'm doing fractions, so 230 on the bottom. 5,000 over 230 is 21.74. 21.7 amps. Okay. Alright, get rid of that for now. Move out the way a little bit. Okay, so 21.7 amps. So looking across at the table, we can see why it's been selected. So 4mm down column 1, 4mm cable. First one along is single phase, can carry 26 amps. If you look above to 2.5, it can only carry 20 amps. So 26 amps is what we're wanting because it's bigger than the 21.7. So we know the selected formula for a good reason. Okay, so what I want to do now, guys, is go down to the next page, which will give us our millivolt amps rating. So I shall move that out my way. And we're going to have to rotate the view around on this a little bit. And that's somewhere. There we are. Rotate page. So reference method A and B. So we've got the conductor size 4mm. It's AC reference method A and B, enclosing conduit or trunking. It's millivolts per amp per meter. So the millivolt number is given in the table. So 4mm has a millivolt reading of 11. So I'll write it down. So millivolts per amps per meter. So the millivolts is 11. Okay. And it's milli, remember. So anything that's milli, we're going to end up dividing by 1,000 at the end. So times that by my current. So current we got is 21.7. Times by length. It's given in the question as 25 meters. If you look past my head, 25 meters. So times by 25. Because it's milli, we divide by 1,000. Okay. And I'm going to pull the calculator back on. I'll put it in place to the regs book because we don't need that anymore. So we'll clear the calculator. Fraction symbol again. 11, which is my millivolts, times by 21.7 times by 25 to the bottom, divide by 1,000, and it gives me a current, a voltage of 5.97 if you round it up, so 5.97 volts. That's my volt drop. So V drop. Okay. So as far as this question is concerned, that's pretty much it. However, I always go one step further. So we're looking at the maximum volt drop. So max voltage is 3% for lights, 5% for power. Okay, the question doesn't actually specify what it is. So it's a single phase circuit, 5 kilowatts, so more than likely it's going to be a power circuit, but you never know, you can get some big floodlights. You're looking at sports pitches, so we'll go for the worst case scenario of 3% lights. So 3% and 5%, we'll work both of them out. So 3% of 230 volts, so 230 times 0.03 is 6.9 volts. And 230 times 0.05 by 5% is 11.5 volts. So my voltage is 5.97, which is less than both of these. So 5.97 volts is less than 3% and 5%. So would be acceptable for use in lighting and power circuits. So although they may not be looking at that, it shows you strong understanding of the question. And going through the exam paper, they realise, yes, this person does know what they're talking about, they've got that understanding and not just guessing through it. And it'll come in use anytime used in the future. Anywhere you use voltage drop, it's there for a reason. You need to compare the figures to make sure that it complies with either lighting or power. So that's nice and straightforward, that one, guys. Hopefully that helped you a little bit. And if it did, fantastic. If it didn't, watch over it again. Do the questions yourself, change the values, change the kilowatt. You could put 3 kilowatts in there. You could change the size of the cable. If it's 3 kilowatt, you can knock it down to a 2.5 cable. You can change the cable from single core to multi-core. You can change to armoured to flat profile, twin and earth. Change the reference method. Try a lot of different scenarios. Get familiar with the tables and how they all work and how the calculations work. Thanks a lot. Cheers.